is Notes 5, page 3. Previously, in earlier episodes, we learned what a negative exponent means. And what we need to do is start practicing with expressions that have negative exponents. The good news is the exponential rules that we learned in the very first notes, they're the same exponential rules no matter what the exponent is, whether it's positive, negative, or a fraction, or an irrational number. So we will not need to learn new exponential rules. However, there are some nuances in terms of working with problems with negative exponents. So the first thing we want to do, though, is practice with the meaning of a negative exponent. So we're going to take an expression, we're going to say it in words, and we're going to simplify it. And generally, and now there are exceptions, so there's always exceptions to rules, expressions are going to be considered more simple, and we want things simple, if there are no negative exponents in the final answer. So initially, we're going to really try to clear negative exponents because they just complicate things. To do these problems, first we're going to say it in words. So this is a negative exponent, and the negative exponent simply means take the reciprocal of the base, and the base here is 8/3, so this just says take the reciprocal of 8/3, which is 3/8. Done. And you can see 3/8 is a whole lot simpler to understand than 8/3 raised to the -1 power. So, again, some of these are written in case I have to do this in class and we run out of time. But this is 5 raised to the -2 power. That doesn't mean much. The negative exponent says take the reciprocal. So take the reciprocal of 5 squared. Okay? So 5 squared, flip it, is 1/25. Okay. Let's look at the next one. And here's where you do need to be careful. Where the negative is changes its meaning. And there's another place when you get into pre-calc, you will see functions raised to the negative first. Well, that's a different meaning, okay? It's a inverse sign. So, and there's a connection here, but this -1, because it's in the exponent, means take the reciprocal. This negative, because it's down at the level of the base, means take the opposite. So, and subtraction before exponents, this is the opposite of, and since there are no parentheses, the only thing you're taking the reciprocal of is the 3. So it's the opposite of the reciprocal of 3. And if you say it that way, it's pretty easy. Take the reciprocal of 3 first, and then take the opposite of that answer, -1/3. Okay, take a second. Pause the video if you need to. Say this expression in words. Don't use the word negative or minus. And I'm going to have a problem like this on your assignment, so don't use the word negative or minus. Say what this is in words first, and then see if you can simplify it. Okay, so it's this whole base raised to the -1, so it's this whole base. Take the reciprocal of that. So we're going to take the reciprocal of, I'm going to leave a blank here, x and y. And if you just put this in, the reciprocal of x, and then it sounds like you're adding y, that would be 1/x and then add y. That's not right. We have to take the reciprocal of the answer to x plus y. So you can say it that way. Or you can say the reciprocal of the sum, because that means to add x and y. but you're taking the reciprocal of the whole answer and you do it as a unit, that would be 1 over x plus y, like that. Okay? So notice the wording says take the reciprocal of the entire sum of the entire addition problem. Okay, so the words correctly describe what we're looking at here. Try this one. Oh, okay, and then we're going to fix this one here. But try this one. Again, pause the video if you need to. You will get more out of things when I say pause the video if you actually try them. And now I'm not going to sit here and leave the video running and bore you to death. So I'm going to go ahead and go through this. And by the way, you have to say this without the word negative or minus. So that negative can be read as the opposite of 2 because it's in the base. That negative is the reciprocal of the base. So this is the opposite of 2 times, there's the times, the reciprocal of 6. And then the language can help me actually figure out how to simplify this. It's negative 2 times the reciprocal of 6, which is 1/6. And so this is negative 2 over 6, or negative 1/3. Okay? Now, this next problem, I think I just got overzealous with my minus signs. I didn't really want that minus sign there, so change the problem, get rid of that minus sign. Now again, take a second, say this in words, pause the video for a minute, see if you can say it in words, and then see if you can simplify it. Okay. So, I'm going to say it like this. Isn't 1 over x the reciprocal of x? And then the negative 1 tells me take the reciprocal again. So I'm going to say it this way. This is the reciprocal of the reciprocal of x. And so if you think about it, if you take the reciprocal twice, you're just back to where you're started. That's just going to be x. So if you flip that fraction, which is what the negative exponent means, you just get x. You could have said the reciprocal of the fraction 1 over x if you wanted to. That would also work. Now typically, and you can see with these answers, if you don't have the negative exponents, it's a lot easier to see what that expression really is. But there are times, especially when you get to calculus, when using a negative exponent actually makes things easier. So we want to be able to go back and forth from having negative exponents in our expression to getting fractions, or maybe starting with fractions going back to negative exponents. So what we want to do is use a negative exponent just for the variable, so that there's no variable in the denominator. And that's actually the point. For certain rules in calculus, life is so much harder if there's a variable in the denominator. So if you could get that variable out of the denominator, life becomes easier. So for this problem, you have to realize that 1 over 3 times x can be broken up as 1/3 times 1 over x. And then there's where that x is in the denominator. Well, 1 over x, isn't that the reciprocal of x? So I could write this as 1/3 times x to the negative first. And now the x is in the numerator with a negative exponent. But that's a whole lot easier to work with some of the differentiation rules in calculus. So pause and see if you can come up with this one. Can you write this so that there's no variable in the denominator? Well, I'm going to go ahead and go over it. Hopefully you paused the video and tried. One thing you want to realize that helps is this can be broken up as x times 1 x over 1, excuse me, times 1 over y squared. The y squared's in the denominator, so it's like you took the reciprocal of y squared. So why don't I write it that way? X times y to the negative second, which means the reciprocal of y squared. And there you go. Okay? All right, so we'll practice more with negative exponents, get into sort of deeper problems in the next page.